Hello and welcome to the Terran Space Academy, where we help prepare you for a bright future in the space industry. Many of us dream of forming our own space company, so that we can play a part in building the next frontier. The Academy is starting a series of lessons, where we will showcase space entrepreneurs, those who have made it, and those still building their dreams. A special thanks to our contributors, who make it possible for us to continue our work. Let's look at one company's struggles to make their dreams reality. John Chisholm was born in 1923 in New York, but grew up in Canada, attending St. Francis Xavier University and later MIT. At MIT, he earned a master's degree in electrical engineering. Apparently, he was also quite athletic and an excellent boxer. He was hired by Bell Aircraft after graduation and helped develop an electronic landing system for aircraft carrier landings. He married Doris Buckland in 1956 and raised 5 children. In 1963, at the age of 40, he and Doris founded Sierra Nevada Corporation in Reno. He seems to have been an engineering genius, and through his company, continued developing advanced electronic systems for aircraft. Many of the contracts his company acquired were for retrofitting U.S. military aircraft with advanced electronic surveillance and warfare equipment. In 1981, John hired Fatih Osman. Fatih was born in Turkey and was an accomplished cyclist in the 1970s, competing in the Tour de l'Avenir in France in 1977. He received his master's degree in electrical engineering from the University of Nevada at Reno with a thesis in navigation and landing systems. Sierra Nevada Corporation was successful, and John was elected to the Nevada Inventors Hall of Fame in 1991. By 1994, after more than 30 years building and running his company, and at the age of 72, John was ready to step back. He sold SNC to Fatih and Aaron. They still own the company today. Running a company that is dependent on U.S. government contracts is very tricky. You would hope that simply providing the best service and price would get you the contracts, but that is not how it works in America, at least not anymore. The fall of the Soviet Union was heralded as a great victory for the United States, but without a powerful adversary to defend against, the U.S. became complacent. By the 1990s, America was sliding into an era of graft and corruption. Military contracting was no longer seen as vital to the security of the nation. The world's only remaining superpower did not really fear an outside attack. But U.S. defense spending remained high and became a way for politicians to shift taxpayer money to their corporate friends, who would later hire those same politicians or their family members. With the U.S. Supreme Court's Citizens United decision in 2010, directly bribing politicians in the United States became essentially legal. Companies that tried to get by on the quality of their work alone would end up with no contracts at all. You had to make the right friends to survive. In 2001, Sierra Nevada had about 20 employees, when they formed a political action committee. These committees are created under IRS Code Section 527. These are lobbying organizations that funnel private money to public officials to influence their decision-making. Some would argue that these committees funnel money to politicians that already share their goals, but this argument requires a complete denial of human nature. By 2004, Sierra Nevada had received a no-bid contract worth $4 million to modify military helicopters. This contract had been awarded by Jim Gibbons. Mr. Gibbons was a U.S. congressman from Nevada. In 2006, it came out that Mr. Gibbons had also given a contract to a company owned by a personal friend of his, a Mr. Warren Trepp. Mr. Trepp had paid $10,000 for a vacation for Mr. Gibbons and his wife, in addition to $100,000 in campaign donations. Mr. Gibbons, in return, had earmarked a several million-dollar contract to Mr. Trepp's company. This started a federal bribery investigation. This was before the 2010 Supreme Court decision, so giving money directly to politicians in this manner could still be prosecuted. Trepp's wife had sent a message saying, "Don't forget to bring the money you promised Jim and Dawn," to which Mr. Trepp responded, "Don't ever send this kind of message to me. Erase this from your computer now," which is arguably a much more stupid thing to send than his wife's original message. In the course of the investigation, it became known that Senator Gibbons' wife had been paid about $35,000 in consulting fees by Sierra Nevada Corporation before the no-bid contract was awarded by Senator Gibbons. These fees from SNC and the money given by TREP had not been reported by Gibbons to the government. The President of the United States was, at that time, George W. Bush, a member of the same political party as Mr. Gibbons. The federal prosecutor investigating Gibbons, a Mr. Bogdan, who had been appointed by Bush in 2001, was then suddenly let go without explanation, and the investigation faded away. Mr. Gibbons went on to be elected governor of Arizona in 2006, resigning his congressional seat. I bring up these points not to defame the company or the congressman. No one was convicted of a crime, but to point out that running a company in the United States is like navigating a minefield. If the politicians don't like you, it doesn't matter how innovative your company is. You will get nothing. Just ask Mr. Bigelow, the billionaire that spent a sizable part of his fortune building space habitats that NASA continually refused to use. But to make the politicians like you, it is necessary to do things for their benefit. Whether that crosses the line into criminal conduct is determined not by some objective measure, but by who is in power. In any event, the senator became governor, and Sierra Nevada continued to get government contracts. In 2008, Sierra Nevada Corporation bought a smaller company called Space Development Corporation, or SpaceDev. SpaceDev had been working on this. This is the Dream Chaser spacecraft. The Dream Chaser was based on the HL-20 personnel launch system. It has long been felt that a horizontal landing craft is safer than a vertical landing craft for human spaceflight return. Getting a shape that can both glide and survive re-entry is difficult. The Soviets had accomplished this in 1965 with the MiG-105. MiG stands for Mikoyan Gurevich Design Bureau. This was planned to be a vertical launch horizontal landing spaceplane that in turn was probably influenced by the American X-20 Dinosaur, which had been designed in 1957. The Americans had considered this for human spaceflight back in the 50s, but decided on the Mercury capsule instead. The Soviets had also realized the effectiveness of this design, and while the Dinosaur was never built, the MiG-105 was constructed and tested in space several times. In the end, the Soviets also went in a different direction. But the idea was revived in the 1960s, starting with the M2F2. These were dropped from B-52 bombers, and testing proceeded through the M2F3, X-24A, X-24B, and the HL-20. The HL-20 was originally designed to carry up to 12 people to a space station after launching on a Saturn 1B. A Saturn 1B was a two-stage rocket capable of taking 21 tons to low Earth orbit. It had an RP-1 first stage and a hydrogen-powered second stage. The HL-20s would only experience 1.5 to 1.9 G on re-entry, which would be important for evacuating a sick or injured astronaut, as well as for transporting general public personnel into space. The wheeled landings made it possible for these ships to come down almost anywhere in the world. In the 1970s, it was hoped that these would complement the space shuttle, but funding became scarce after Apollo and the space shuttle, and the HL-20 concept was shelved until the 90s. In the 1990s, the concept was revived, and mock-ups and flight simulators were made by Lockheed Martin and universities in North Carolina. After considerable design development, the HL-20 personnel launch system was shelved again. SpaceDev had been founded in 1997 by Jim Benson. Mr. Benson was an aerospace engineer that wanted his own space company. Mr. Benson first bought a company called Integrated Space Systems, a small space service company in California. He then purchased a publicly traded but inactive company from Colorado, thereby creating a publicly traded space company without having to take a new company public. Pay attention, class. This is how you get things done. He named the new company SpaceDev. A publicly traded company sometimes has better access to financing, and SpaceDev was then able to purchase a UK company called Space Innovations Limited, and after that acquired all the patents and intellectual property of American Rocket Company. The American Rocket Company had mastered the construction of hybrid rocket engines, but had bad luck during the launch of their sounding rocket SET-1. Moisture from the air froze around the liquid oxygen valve, allowing it to only open to 30%. The rocket failed, and the company ran out of money without being able to try again. AMROC, as it was called, became insolvent in 1996 and was picked up by SpaceDev in 1999, probably at a very good price. Hybrid rockets are very interesting. We have covered these in several classes, including this one on Virgin Galactic. But briefly, hybrid rocket engines use a solid fuel with a gaseous oxidizer. SpaceDev began promoting itself on the internet, and people started to take notice. That's good and bad. Potential customers will learn about what you have to offer, but your competition will learn that you are after their market share. It has become a rite of passage for established companies to use their purchased politicians and the legal system to pressure and harass any potential rivals. We're looking at you, Jeff. In 1998, the Securities and Exchange Commission filed securities fraud charges against SpaceDev, claiming they were exaggerating their capabilities online. You will notice the big companies don't have this happen, nor are they called to account when they completely fail to perform a contract. A settlement was reached, and Mr. Benson agreed to be more careful. SpaceDev worked on a lot of space projects, including the Near-Earth Asteroid Prospector and the Cosmic Hot Interstellar Plasma Spectrometer. They were the first to create a small satellite in low Earth orbit that used only the internet for its communications. SpaceDev went on to use the technology developed by AMROC to build the hybrid rockets that sent Spaceship One past the Kármán line and is still being used on Spaceship Two today. And the question becomes, who is responsible for the success of a concept? The person who first conceives and designs it, or the one who makes it a successful reality? In 2005, SpaceDev refined the HL-20 concept and announced its plans to make it a smaller 4 to 6 person carrier. In 2006, SpaceDev was selected as a finalist for a $500 million commercial orbital transportation service contract to develop the newly named Dream Chaser into a space taxi. Mr. Benson stepped down from SpaceDev the same year to found the Benson Space Company. He hoped for this to be a space tourism company that would use the Dream Chaser to take tourists into space. NASA, however, did not select the SpaceDev Dream Chaser for the program. Mr. Benson had his new company pay SpaceDev $330,000 to keep the concept alive. In 2007, SpaceDev announced an agreement with United Launch Alliance to send a Dream Chaser to space on an Atlas V. In 2008, Mr. Benson died of a brain tumor. That same year, SpaceDev was bought by Sierra Nevada Corporation for $38 million. Under Sierra Nevada, things went differently for a while. By 2010, NASA had awarded Sierra Nevada a $20 million contract to continue development of the Dream Chaser. In 2011, another $80 million was given, with another $212 million coming in 2012 to continue development and testing. It always shocks me when I see government contracts given out like this. NASA rejects the concept when it's owned by SpaceDev, then spends $250 million on the same spaceship once it is owned by someone else. And that seems to me like a lot of money to spend without something actually flying. I think SpaceX has changed our expectations on what can be done in the space industry. SNC did carry out a captive carry test in 2012. This is where you have a helicopter fly your ship through the air and study its aerodynamic characteristics. Several drop tests were also performed in 2013, with the Dream Chaser Eagle proving that the ship could glide to a safe landing, though a wheel failed to deploy, causing the ship to impact the runway and suffer some damage. In December 2013, the German Aerospace Center announced interest in using Dream Chaser technology for European Space Agency purposes. By 2014, Sierra Nevada was able to buy a company called Orbitech. Orbitech had an advanced vortex rocket engine. A vortex is a pattern of spinning fluid, like a cyclone. A vortex rocket engine uses a cooler outer vortex of gas to shield the engine compartment from a hotter inner vortex of gas. This is accomplished with a swirl injector. Here you see a vortex engine firing, and here is a transparent one, so you can see what is going on inside. This concept can increase rocket efficiency without damaging the engine. The Orbitech engines used liquid propane and nitrous oxide propellant. The hybrid rocket engine on Dream Chaser was replaced with Orbitech's vortex engine technology. In 2014, it was announced that the Dream Chaser would have an autopilot-controlled orbital test flight in 2016. However, also in 2014, NASA rejected the Dream Chaser for further commercial crew development, selecting instead the Boeing Starliner and the SpaceX Dragon. We all know what happened with the Starliner. I will never agree with the U.S. government's habit of giving larger companies more money to do less. That's how we kill innovation. It turned out that a high-ranking NASA official, Mr. William Gerstenmaier, had opted to rank his friends at Boeing higher than the experts reviewing the ships had, allowing Boeing to get the $4.2 billion contract, while the smaller company, SpaceX, got just $2.6 billion to accomplish the same goal. And Sierra Nevada got nothing. Sierra Nevada sued the GAO but lost, with the Government Accounting Office finding that somehow the Dream Chaser's unflown propulsion technology was less mature than the Starliner's unflown technology. Boeing has basically wasted that $4.2 billion of taxpayer money. Starliner will not be going to space anytime soon, while SpaceX is routinely flying crew to the ISS in its Dragon capsules. And with the money wasted, we could have Dream Chaser and probably at least one other fully developed spacecraft. The Dream Chaser was redesigned for cargo only and was supposed to fly in 2021, but this has been delayed until 2022. The Dream Chaser Ascension has been built for more drop tests, and Dream Chaser Tenacity is to be flown on the SNC Demo 1 mission. The Tenacity will have the innovative Shooting Star cargo module, which is derived from Lockheed Martin's Jupiter Exoliner concept. The Tenacity will have a cargo capacity of 5,500 kilograms to the ISS, while the Shooting Star will have a cargo capacity of an additional 4,536 kilograms. At the end of its mission, Shooting Star can be allowed to burn up in the atmosphere, with refuse from the ISS, or stay in space performing experiments, while Dream Chaser can return from the ISS, with up to 1,750 kilograms of cargo. This system can be used to return experiments without exceeding 1.5 Gs. But Dream Chaser has a problem. It has to fold its wings and fit in a fairing. These fairing comparisons show that only something as large as Atlas V, the Ariane 5, or Vulcan can get the job done. The Demo 1 mission is planning to use a Vulcan rocket, which I find stupid at this point if you hope to fly in 2022. But what can you do? Only these rockets are big enough to get the job done. But we have a suggestion. The Falcon 9 fairing is too small for Dream Chaser, but SpaceX is developing an extended payload fairing. This extended fairing is planned for use with the Lunar Orbital Gateway. The components of the gateway will be launched on a Falcon Heavy rocket, instead of the SLS as originally planned. If even NASA can correct course, there's no reason why SNC cannot. Sierra Nevada should seriously consider changing their plans for Vulcan, and use the Falcon Heavy with the extended fairing instead. The Falcon Heavy is a proven design with sufficient Delta-V, and it has actually flown. The Vulcan can't even start testing until Blue Origin produces a functional engine. And Falcon 9 is cheaper. The U.S. Space Force is willing to pay $224 million for the Vulcan to fly up to 27 tons to low Earth orbit, while they will pay just $160 million for the Falcon Heavy to launch up to 64 tons in expendable mode, where SpaceX does not save the boosters. The Dream Chaser has a length of 8.84 meters and a wingspan across the tips of 7.16 meters unfolded. It has a mass of 9,000 kilograms, and it will be loaded with up to 5,500 kilograms of cargo, most of that in pressurized storage. The Falcon Heavy could launch this mass to low Earth orbit, recovering both side boosters but expending the core booster, for only $90 million. Only in the space industry are you allowed to say, for only $90 million. Anyway, the Shooting Star is 4.6 meters long and can carry an extra 4,500 kilograms of cargo. It can also generate up to 6 kilowatts of electrical power. Dream Chaser and Shooting Star could launch on Falcon Heavy in fully expendable mode with the extended fairing, and Sierra Nevada could still save over $80 million. Something to think about. Thanks for listening. Please don't forget to like and subscribe, and stay safe. At Astra Pro Terra.